This is the last video in this series, but next week I'm going to be filming a whole series all about De Moivre's theorem. That's a super popular IB question and a further maths A-level question. So don't think that you're finished just because this series is finished. There is always more math to learn. In this case, we're going to use the rule that we just proved in the previous video to divide two numbers that are in polar form. The rule said that we should divide the modulus, so 6 divided by 3 is going to be 2, and we should subtract the angle, so that's going to be 60 minus 30 degrees is going to be 2 cos 30 degrees. If the question asks you to go back to Cartesian, from then you would just do 2 cos 30 add I sine 30. Cos 30 is, let me visualize my triangle. Cos 30 is square root 3 over 2. And that's going to be a half. Expand. And you have your answer, if needed, in rectangular or Cartesian form, depending on what your teacher calls it. Now, the last question we're going to do is we're going to calculate the answer to this. Instead of writing it as a fraction, they've used the division symbol, but it means exactly the same thing. And now we're in radians. So we need to start by dividing the moduluses. 5 divided by 10 is a half. And we need to subtract the angles. Pi over 4 minus pi over 12. As always, we need to calculate our common denominator. I'm going to go for 12 again. So the pi is fine, but this needs to be times by 3, the numerator and the denominator. 3 pi minus pi is 2 pi over 12, and that's going to be a half cis pi over 6. And again, you're always doing that little mental check to check that your answer is between plus 180 and minus 180, and that the answer is in fact in principal argument form, which both of these pass the test. Cool, guys. So I'll have a little break and then I will see you in the next series on De Moivre's theorem. Please like and subscribe. I love making these videos and I love to hear your hopefully positive feedback, and I will see you in the next series. Goodbye, guys.